start with a question to Dr.
Do you
Lucy.
want the microphone? Or do you want to stand up?
I'd like to.
Uh-oh, watch out.
I'd like to ask a question to Dr. Lucy. How is it possible? How do you grow extra gammadelta cells if it's possible to grow them more than what you've normally got?
Yes.
So the question was, how do you grow more gamma-delta T cells? So that's right. Yes. So this is a really important question. So what we think that we possibly can do is to isolate them from healthy people that have had CMV, which is a large proportion of the population. We can, by the use of a fancy machine, sort them into the right activated group, and then we can put them in a dish and put them in an incubator and put on cytokines, so chemicals, that will make them divide. And then they can divide to huge quantities actually by using that artificial system, and then we can infuse them into our patient. That's the grand plan. Those particular steps involved absolutely need to be nutted out. We haven't got a good handle on that yet, but some really good research. So I work with a postdoc, Sandra, and she's got some really lovely data showing that you can expand them in the lab up to sort of fourfold, even in 7 days.
My question is, and I think you've all kind of answered in part in your presentations, but I'm just curious as to, I mean, I understand that when you have a transplant, you've had a foreign body put into your body, and your immune system goes home and says, this is, we've got to reject this. Is there never a point where the immune system finally just accepts that there's this new thing in your body and says, I don't need to fight this anymore, it's there, I can live with it, and therefore potentially reduce the risk of infections and also the need for sort of drugs to counter that?
What you're talking about is the holy grail of transplantation, and if we could fool the immune system into not seeing the graft, be it cells or an organ, that would be just perfect. And that is something that people have tried very hard to do. There are lots of workshops, lots of people working on it, but it's still not possible. And as Steve was saying, that what we want to do at the moment is go as close as possible in identifying beforehand the matching of an individual organ. But we need, in the future, we would hopefully be able to find some way of mismatching and still having a therapy or having a way of the immune system not seeing it. But it's never possible at this point. To all intents and purposes, not possible. There are individual, very small, point something of a % of cases that could stop the drugs, but only a fraction.
I think, Greg, just saying that liver transplantation is probably the closest where they have the least amount of drugs required to stop them rejecting, and that's because, and I was interested in your graph, Steve, of showing that the liver at the top has the least amount of HLA, and therefore the matching is not nearly as important. And if you saw where lungs were, where we have lots of HLA, that's why the lungs are the hardest. And also too, the fact that the lungs are exposed to the outside environment, so we get bugs and everything in it. So the lungs are the toughest out of all. And
yeah, I think it's also true that it's now being understood that it's not a matter of time you get further from the transplant where you're safer. There's a sort of a minimum level, and maybe Steve and the team are working out where that level is, and if you're above it with the medicines, then nothing happens. But if you get an infection or for any reason your medicines are too low, then that can manifest as a problem at 1 year or 20 years. And just trying to work out where that real level is again the holy grail for us. And I think we are closer to that.
And the liver's full of gamma-delta T cells, I'm just saying.
Ben, with the physio, are you going to long-term look at patients and do a follow-up sort of a program that they should be doing?
I think that my kind of niche interest is more like the acute care critical care down in intensive care and then transition up to the ward. The good thing is, we work pretty closely with Lou as well, and kind of her baby is subacute care and looking at sort of longer term outcomes. So we're just trying to make sure that our research trajectories don't overlap too much, because I think we'd be doing too much of the same thing, but they should mesh together nicely. So I guess that's where we're going with that. Yeah.
I can also announce, somewhat in confidence, that Louise has just been awarded a Churchill Fellowship. I've discovered that this afternoon to actually, yes, just for those people, yes, it's embargoed, but don't worry. To study just that, to study what is exercise for life in a transplant setting. That's exactly her. So a Churchill Fellowship is a very long and hard multi-step selection process to choose a small number of people to travel overseas and spend time in other centres, picking up on ideas to come back, create a sort of mini thesis on it, and then put that into practice. And that's been very successful here with a number of Alfred staff, and a small number of Alfred staff in the past, including Bron, who have had that. So we're looking. It's a great award for Louise for all her work, and we'll be very interested to hear how she goes with it. In confidence.
Steve, I've got a question. With your research and what you're doing there, are you going to ultimately aim to get rid of the direct cross-match? My favourite hobby horse, waiting for direct cross-match.
Improve cross-matching techniques. I'm not trying to get rid of the actual cross-match itself. No. But,
For your job.
Well, my job is not to get rid of the cross-match. We've got improved techniques now. What we currently do, not many centres around the world actually do, and a lot of the work that we could be doing, a lot of our attention could be doing better, improved antibody analysis beforehand, identifying more things. As to the cross-match on the night, I think there'll still be a spot for cross-matching. What level of that is, we'll find out hopefully in the next few months. But no, I don't plan on getting rid of it.
Your slide about, I'm trying to grapple with that slide that had the all the good lung biome, and then at the other side all the bad, and you actually found out you needed some bad and some good. But is that post-transplant? You need the bad and the good, and so you're looking at doing a fecal transplant for people with bad bowel problems. So you're looking to introduce these folks into the post-transplant lung? Or?
So the samples were from post-lung transplant, but this is something we think is consistent just in any lung, any healthy lung. You want to have a balance of those signals because it gives your immune system all the right indications of how to behave. The idea of sort of lung probiotics is something that's really popular at the moment. It's still quite a long way before it will get translated to inhaling a bug. We're not far away from inhaling the metabolites which the bugs produce. And that's something that we're really interested in pursuing as a way to, rather than try to change the bugs, we just change the things that they make. For fecal microbial transplants, and which is really efficacious in a number of disease settings, to my knowledge, it hasn't been done in a lung transplant context, but it has been done in bone marrow transplant, for example. And there is some interest in trying to shape the microbiome into its most healthiest possible state prior to transplant. And maybe that's something for the future, for the gut at least.
And was that only for people with pulmonary fibrosis or any lung?
What we did was all comers lung transplant. And so our main readout for health of the immune system was fibrosis, but it's not limited to that. It was just our readout in that experiment.
I've got another question. Ben, you mentioned that the microbes in our gut, that the microbes in our gut have an impact on how we think. Now, to me, it cuts them all the way from there. How do they have that impact?
That's one of my favourite topics. How long have we got? No, but more the gut lung axis or the gut brain axis is something that I think is really interesting, because we're not talking about microbes going to the brain or to the lung from the gut. We're talking about the metabolites that I was just talking about before, and how that's the chemicals which the microbes are producing. And most of the microbes are in the gut, and they produce lots of chemicals, and they have effects in the gut, but they also go into our blood and then go all throughout our body and influence our organs. They can influence neurons, they can influence... so serotonin isn't microbially derived, right? No. But there are lots, so some of the most popular ones linked with the brain at the moment, or what's known most about that from a microbial perspective, are called short-chain fatty acids. And these are when bacteria ferment fibre in our diet, and as part of that process of breaking down the fibre as an energy source, they produce short-chain fatty acids, and these have been shown to influence the brain as well as the lung and the gut. And so that's where there's a lot of research at the moment, but now we're identifying a whole new range of metabolites and trying to figure out what they do.
Your role as a clinical research coordinator means that you are one of the main contacts with patients that are being asked to go into studies. And I'd be interested from your point of view, what are the common questions that the patients ask you about being asked to participate in the studies, and do you think it's important that we be able to give feedback to patients about what we're doing?
Yes. For the first part of the question, I find that I'm fortunate to be working with patients who are really quite engaged and committed to their healthcare. So they actually understand a lot of the research as it's explained to them, which makes their questions really quite valid and interesting. A lot of them ask about past research that we've done as part of it. They also ask about how this research will impact in the future. They have the knowledge that a lot of their current treatment is actually being based on research we've previously done and produced, and they're also very committed to hoping to make change in the future. Most of ours is very, there's no guarantee that the research they're going to partake in is actually going to have any impact on them directly, and so they are just really keen to be engaged in improving lung transplant in the future, and not as very, I guess, they volunteer to give a lot with not any chance of reward really with that comes. So I find that the questions are very interesting, they understand it and they take it on board and they commit themselves wholeheartedly to research within the unit, which is wonderful. I do believe that the circle, as Ben mentioned, needs to be fulfilled. They need to know what's coming out of this research, and it's really great to be able to show them how it links back to changes in practices. Recently we've changed a few practices based on the findings of research that was done, and our research runs for multiple years, so they wait a long time for these results. It can be 6-7 years before we actually complete it, and it's really nice to say this is how it happened, and present it in forums where they can actually get this information back, such as these ones, whether it's written pamphlets, whether it's a letter that gets sent out to them, and the doctors feeding back to them, because they are the ones who've been see them at the coalface day in, day out after their initial commitment to the research is completed.
Okay, Carmen, you don't escape either. So, how do you, because you're working in the lab, how valuable is it for you and your colleagues to be working with real patient samples rather than just cells and other things that don't come from, real patients as such? And what do you think about that when you're actually looking at the cells and the solutions and stuff that you're working with in the lab?
Well, I guess we, directly looking at Ben's research, we couldn't do the work without the primary cells that we're getting from the patients. It's fundamentally important in that work, and the work we did. I also helped Lucy with the collection of her samples as well. You cannot, we would not have projects without the generous donation of these samples from the patients. And I think we all count ourselves very fortunate to be able to work with these samples, because it's a world of difference between dealing with like a cell in a dish that you may have been around for years and then actually dealing with a primary cell that can give you so much information. And the amount of information that we can get from just a small amount of sample from people is just, it's phenomenal. So, yeah.
And do you enjoy getting the feedback and the interaction between the clinicians and the lab? Does that help make it?
I think it's good. I think it also brings things into perspective when you, having worked in other areas of research without that kind of contact, it also puts things into focus on where the research is actually heading in the future. And so it gives you that, I don't know, a little bit more of a drive in seeing what these outcomes will be in the future.
Anyone else with some questions, or will I just keep going with all of mine? I've got a lot. Okay, Ben Marsden, Dr. Ben. Oh, we've really got two Dr. Bens here. What are some of the key differences that you have seen since you've been back or working with our team here at the Alfred versus what you saw in Switzerland with regards to the way research is funded and conducted? Is there a lot of difference?
Basic research is quite hard to fund anywhere. So it was a bit easier in Switzerland, but it's certainly harder here. I think in Switzerland the difference, probably the advantage, was that funding was dependent upon scientific excellence, irrespective of what you did. So it could be really translational, like what Ben is doing, or it could be whatever you're doing. Could be looking at gamma delta.
Good to see you listen to the talk.
As you said, the gamma delta cells do stuff. But it could be really fundamental, trying to understand what gamma delta cells do, and that would equally be considered as being scientific excellence. But here I've noted that it's really, the focus is often quite short term and on giving a result in a short period of time. And as Evie said, it takes a long time to do our work, and we can't always deliver straight away. And so probably some of the fundamental research is undervalued here, more from the political environment as opposed to, as opposed to the scientists or the local environment.
One of the questions I sort of wrote down, there is a slow but steady demise in NH and NIC funding around the country, around Australia at the moment, and less projects are being funded by government. So how important is it to find other avenues of research funding, like what comes from Lungitude and other philanthropic organisations, then to keep research going?
Yeah, I mean, it's critical. I mean, it's a small pool of money that we're trying to access in order to drive our research. But I think, so we need to diversify away from a single government source. But I think the key thing for me, and it's particularly relevant here, but it was also relevant in Switzerland, is finding the right partners. And you actually want to find partners that buy into the same vision and you want to do something, whether that be basic or translational or whatever. And I think that's the most important thing in the way we're most effective, both from a practical viewpoint and progress viewpoint, and also from spending the money wisely, is finding the right partners. So that's why it's nice to connect with people sharing the vision of what we want to achieve. I think that's the most important thing.
All right, so Lucy, as a champion of women in science and research, what are some of the specific challenges you've had in regards to, say, competing for research funding and actual research projects compared to what you might have seen, say, male colleagues? I'm being very
Right, we're going to open up that can of worms, are we? Okay. All right, how long have we got? Right, so yeah, there's a curiosity of both the NHMRC and the ARC, which is the best way of getting funded apparently is to be called Dave, or Ben maybe. There was more Daves than any other, or David than any other. I think more Daves than women one year. So yeah, so it's tricky, and I guess the thing, it's not necessarily a conscious thing. It's about unconscious bias, and we all have them, which makes it really hard to tackle this problem. So, what does a scientist look like? What does a nerd look like? You probably wouldn't, picture maybe us, but it's the same thing even with scientists reviewing other scientists' work. If you had somebody called, I don't know, Candy versus somebody called Dave, like you might just, there's a prejudgment there, and that's something that's really tricky of dealing with. But the unfortunate consequence is that in these schemes there is a huge bias towards funding male-led research. Sorry? Do you want me to get off my soapbox? Is that
Can I ask a question?
Sure.
Lucy,
Yes.
so the Doherty Institute fellowships this year, what was the breakdown of male and female, and was something done right by the Doherty Institute?
So what Ben is alluding to is the NHMRC have restructured their system now that there's a whole new scheme, and this scheme where fellowships are being replaced by investigative grants. So at my institute, 90% of, we actually only got 7 grants, but 6 of them went to women at the Doherty Institute. So I'd like to think that's due to my work in... But look, we are surrounded by amazing women, and to sort of perhaps we are starting to see those shifts happening, which is great, but yeah, certainly we've still got improvements to make. I'm not...
First year.
What's that?
First
Yeah,
year,
exactly. So there's
history.
always cycles, so let's wait and see what happens. Hopefully that, not to that level, but we're only asking for 50-50. Let's see what happens over the next few years.
Question, is there any type of treatment that you can give to the donor lung prior to transplantation to prevent what may come in terms of rejection?
There's definitely work being done on that. The lungs can be put essentially in a parking mode on a machine outside the body for an absolute maximum of 24 hours using existing technologies, and there's a group in Canada who are actually using a virus in the lung that gets into all the tissues in that time and releases inflammatory chemicals that actually block the rejection process, and the thought is that might actually be quite helpful in the longer term. So there's definitely interest in doing that, and there are ways people have thought of pre-treating the lung, and there's even the idea of having like a lung repair shop where the lungs get sent to and sort of cleaned, polished, treated with various things, and then passed on to the transplant centres. And it sounds science fiction, but there is literally one set up in Maryland based on the Toronto system, and that is exactly what they're trying to do.
So I think they're going to start treating the microbiome of the lung, maybe. Is that potential? Could be of use too. John? Yeah.
Is the lack of funding for research largely to do with the fact that people don't understand what you guys do? I mean, the presentations here today, I'm a layman, the presentations here today are very exciting, even on my limited understanding of them. But you're talking to people who are politicians who are there for a pension in a couple of years, and you're trying to explain something that's really probably not going to be affecting them until they get sick, and they haven't planned that far along. Isn't that more of a bigger concern like sexual bias?
I'll leave the last part of the question for Lucy. But I just want to make one observation. One thing might come down to ability to communicate science, which is not easy when it's complicated. But one thing I noticed in Switzerland is scientists are actually respected. Even in the hierarchy of geekness, a scientist is respected more than a clinician, which is the opposite of pretty much everywhere else. In New Zealand, you're going to be a scientist, and that's just weird. Why? If you're going to be a clinician or a doctor, then I respect you. And maybe that's also something about that science may not be understood very well, maybe we're not communicating well, but on a social level also scientists are not necessarily respected. Whereas in Switzerland, you'd go and to a public talk and it would be sold out, packed, because everyone wants to learn about it and sees value in intellectual advances.
Yeah, so the amount of funding that's donated to research is I think it's 0.3% of GDP. And it's 10 times that in a lot of other countries. So no matter which way you slice the pie, not everybody's going to get a piece, no matter what happens. grants. So, and unfortunately now at the moment we're down to around 8% of grants that get funded through government schemes, which means a lot of really stunning research is not getting up. So, but your point about selling it is actually critical. That it is our job as scientists to make people understand and make our research accessible. Because if we can't do that, then we're not doing our job, and we probably shouldn't be funded.
One of the things when we did the Centre of Excellence, we contacted both politicians, state politicians, but also the federal politicians. We talked about what the Centre of Excellence was we realised there was an absolute lack of knowledge in post-transplant care. Everyone's really excited about doing more organ transplants and doing transplants because they get paid more money. So, but they're not really, after that, they don't care about the aftercare. But what they don't realise is the more we spend on research about why we have rejection actually means the matching process actually comes to the full circle as well. So, what we started this Centre of Excellence about post-transplant care, what the Centre of Excellence looks like is, imagine a 5 or 6 story building. Yes, you've got your post clinic there, but you've also got your research, you've got your economic centre, you've got your social centre. What I mean by social centre is almost that mental care, a bit of the health side of it, is because as carers we suffer mental health of the practitioners as well, but also the mental health of the patient, and bringing everything together. And that's actually world's best practice. There's not a centre of transplant excellence anywhere in Australia. We wanted to set it up in Victoria because of the issue we have with lungs at the moment. And then from there we can translate that, again, going back to this translational research, back across to all of the states. What we also found out as we're doing this is that the sharing of knowledge is absolutely critical. Here we've just got a small sample here, but if you think about all the other research doing across all other transplants, how easy it is to share the information, yes, then we can get more funding on it. So part of what we're doing, part of the advocacy for the Centre of Transplant Excellence, is just to talk about having a building. It's about understanding what these people are doing. Because a lot of the work that we're funding from Lungitude perspective is this grassroots type of research, because no one really wants to fund that. They want to fund the stuff that's going to save the world, and be that wonder drug or that wonder experiment that stops transplants happening, but no one actually wants to fund something which we actually don't know what the outcome is. So that's what we're doing from a Lungitude perspective, to help these people stay in the job and stay with us. One of the biggest problems we had about 8-9 years ago was researchers, well, there's no funding. So they were going into 2 years of a PhD, and then so there was no funding, and they were walking up into other jobs. And we were losing that a lot of research. We've actually lost a lot of technology in Australia that's gone over to the US because we don't want to fund that research. So the whole point of Centre of Transplant Excellence is to bring everything better back into one room or one building. We can do a lot more translation stuff on that side.